Okay, we're going to get two special types of factoring that we can use. You can factor them like normal, but we can also use some shortcuts. So just some reminders before we do that. Just remember what opposites. So if we have opposites, for example, 5 and -5 are always going to add up to 0. And then when we're doing squares, so a number squared and taking the square root of that number are opposites. And then another reminder, factor square, so that if I have like x minus 3 and then I have another x minus 3, so a shortcut is we can say that that is x minus 3 squared. Alright, so let's look at the first type of problems first. We're going to look at these here. Okay, so we're going to use the same method for all these. I'm going to show you the long way the first time, and then after that we're going to use the shortcut. So what this one means is we have x squared, and we don't have that middle term, so it must have been 0, because if it's 0, we don't have to write it. So then we multiply our a times c is -16, and factors of -16 add up to that 0. So I could list all my factors. And then because it's a -16, one of them has to be negative. And then the one that is going to work is going to be this one here, -4 and +4. And because that a is 1, we can go right to our answers. -4 and +4. It doesn't matter what order. Okay, for the shortcut. When we have a perfect square here, so that is x squared, and a perfect square here, 16 is 4 squared. So we can take this x squared and we split it up x and x. Then I can take this 4 squared and split that up into 4 and 4. The way you can check for that is do a square root. So square root of 16 is 4. If you put the square root in your calculator and you don't get a whole number, that means you can't use the shortcut. So let's use a shortcut so we can make sense of that over here on number 2. So I can get my parentheses ready. And then square root of 25 is 5. So that's 5 squared. Square root of 9 is 3, so that's 3 squared. So we can start with our beginning numbers. So we have a 5 and an x in the front. So I'm going to have a 5 and an x in the front of each here. And then I have the 3 at the end. So I'm going to have a 3 at the end here and here. And then to make this a -9, the only way to get a -9 is one's positive and one's negative. So one of these is positive and one of these is negative. Doesn't make a difference which one. So square root of 25 with the x and square root of 9 at the end. So let's use that for down here on number 5. X squared is just x squared. Square root of 64 is going to be 8, so that's 8 squared. So we can get our parentheses set up. And we have x squared in the beginning, so we just have an x and an x in the beginning. And then we have the 8 at the end, so we have an 8 and an 8 at the end. And then we need 1 plus and 1 minus. Again, doesn't matter which is which. The difference, though, with number 5 here is now the directions say find the roots. We notice it has equal to 0 here. So anytime we have equal to 0, that means we got one more step, we have to solve it. So then we have the x plus 8 equals 0, and the x minus 8 equals 0. And this one's going to give me x equals -8, and this one's going to be x equals +8. Okay, number 7. Well, I can't take the square root of 2 or the square root of 50. That's not going to be a special factor. So I could do the 2x squared plus 0x minus 50, and then do my a times c and all that. But if I have said before, we want to get in the habit of, if you always check for a greatest common factor first, then we would notice that I actually have a greatest common factor here. They can both be divided by 2. So if I do that and I divide them both by 2, we end up with this. And then this is a perfect square. and 25 is a perfect square, that's 5 squared. So now, since they're both perfect squares, I can use that shortcut. So we're going to set up our parentheses. We have an x in the beginning, so we have an x in the beginning of both. And I have that 5 at the end, so then I have a 5 at the end of both. And then one's a plus and one's a minus. The only difference is now we have to drop down that GCF that we factored out in front. And again, we're solving this one. We have that equal to 0. 2 can't be equal to 0, so we can ignore that. But then we have that x plus 5 equal to 0, the x minus 5 equal to 0, and we solve each of these. So negative 5 and positive 5. Okay, and let's look at one more just for some extra practice. Let's say we have 16x squared minus 81. So we're going to get our parentheses set up. I know one's going to be a plus and one's going to be a minus. And I look for perfect squares here. We have two. We have 16, which is 4 squared, and then we have x squared. So I need a 4 and an x. 4 and an x. That's at the front, so it goes in the front of each. And then 81 is 9 squared, so I need the 9 at the end. 9 and 9. And those are your factors. And if it says solve, then remember you're setting them both equal to 0, and you're solving. Remember though, on any of these, if you're struggling to remember the shortcut, you can just do that regular AC method where you find your factors that add up to equal 0 in the middle. And that works for all of them as well.